Okay, I think that should do it. Probably. Yep, looks like YouTube is switching. I still need to get used to how OBS is working in the new version. But yeah, we should be live now. Let's also put on some music. I think I fixed the audio. Yesterday I forgot to plug something in because I swapped over CPUs. So yeah, I did a little bit of mixing before I started streaming. I think the level should be okay. If it's still too loud or something, just let me know. So yeah, let me see, do I have the advent of code? Yes. So after yesterday's stream, there were some comments and some code that we looked at. I completely forgot to use, or that zip existed. So I figured, okay, I really like that. Something that I also wanted to do is make sure that I don't do the parsing twice. So in the constructor, I just added the basic left-right parsing, and I adopted this new way of writing it instead of toList. SmapUK can maybe talk about that later a little bit more. So I have two variables accessible here, left and right, which the parts don't have to process by themselves. And then here in part 2, we take the right set, we build up the counts, loop through them, and then sum it. This could also be written differently, but I think this is fine. So yeah, that's basically the changes I made. Let's see what today holds in store. So yeah. Day 2, red-nosed reports. Fortunately, the first location the historians want to search isn't a long walk from the chief historian's office. While the red-nosed reindeer nuclear fusion/fission plant appears to contain no sign of the chief historian, the engineers there run up to you as soon as they see you. Apparently, they still talk about the time Rudolph was saved through molecular synthesis from a single electron. They're quick to add that, since you're already here, they'd really appreciate your help analyzing some unusual data from the red-nosed reactor. Your turn to check if the historians are waiting for you, but they seem to have already divided into groups that are currently searching every corner of the facility. You offer to help with the unusual data. The unusual data, your puzzle input, consists of many reports, one report per line. Each report is a list of numbers called levels that are separated by spaces, for example. Okay, we have a grid of numbers. This example data contains 6 reports each, containing 5 levels. I just noticed that I need to resize this window to make sure that I don't read off screen, because my desktop is bigger than the visible area here. So yeah, let's see. The engineers are trying to figure out which reports are safe. The red-nosed reactor safety systems can only tolerate levels that are either gradually increasing or gradually decreasing. So, a report only counts as safe if both of the following are true. The levels are either all increasing or all decreasing. Any 2 adjacent levels differ by at least 1 and at most 3. Okay, so they both need to be true. So we have 2 things that we need to check. If they're not true, we can assume false. Okay. In the example above, the reports can be found safe or unsafe by checking those rules. Safe because the levels are all decreasing by 1 or 2. Sure, so every number is lower. And then any 2 adjacent levels differ by at least 1 and at most 3. So yeah, the gap is sure. Let's see, unsafe because 2 to 7 is an increase of 5. Oh yeah, so they can be either up or down for both of them. Sure. So 2, 7 is an increase of 5. This one, it all goes down, but 6, 4, okay, yeah, max 3, sure. This one has a dip, increasing then decreasing. Unsafe because 4, 4 is neither an increase or a decrease. Okay, sure. because that's the 1 and 3 rule, right? Save because the levels are all increasing by 1, 2, and 3. Sure. 2 reports are safe. Analyze the unusual data from the engineers. How many reports are safe? So this is the test input. Let's put everything together now. We copy day 1. I should probably make something that just says new day, and it will just do it like that. Yeah, it's fine. Day 2, 2, 2. Let's close all but this. Close other tabs. Okay, that is fine. The test input becomes this. Parsed is the same, so this will become like this. That is fine. So parse is a list of int, so that is fine. So now we can just do list int parsed. Like this. We don't need this. And we can do the same syntax as before. Like this. Code snippet with year and day of parameter. Yeah, something like that. Okay, now we can get rid of all of this stuff. Usually I copy day 0, now that I remember. Apologies. That's why I made this file, to copy and change, but yeah. But yeah, a code snippet would work. That would work. So let's define some rules here. So we do const int min change is 1, max change is 3. And then we need to enforce the direction, right? So we can loop over them. We do for each var values in parsed. And we do bool increase is values 0 smaller than values 1. Okay. Then we can do for int I is sure, why not? It is 0. Max is values that count minus 2. No, minus 1. I smaller than max, increase I, like that. So now we can test basically so what we need to do is test the local increase. We need to satisfy the first rule. So we do values I smaller than values I plus 1. And if we probably should, yeah. The first time you do it double, but that's okay. If I larger than 0, we can just do it like this. And then like this. If L increase not equal to increase, ground rule. Set of values breaks the continuation of increase decrease. Something like that. So that takes care of the first argument. And then we need to make sure if something tells me that I should have like a current and next val, and then always just update, swap them over, and then do it like that. But I'll just write out the logic for now. So we can do int diff. I can do int cur next diff. So we can do cur is values 0. Next is values 1. Current smaller than next. Basically, what we can do is pom 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 pom. Haha, and this would trip me up, because the logic that I would want to do is like, okay, current is next, but you only do that if this is larger than 1. So you do, hey, that is it's a tricky one, because you need to do it twice then. That's annoying. Boom, 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 boom. So you would do next is values I plus 1, like that. Basically, you need to test this twice, because you need to do it. Do I need to do it there? I'm just thinking in my head, like the first time I don't need to check, I just need to change it, but I need to make sure that I do the difference check. So what you need to do like is if math.apps apps next and then cur. First we need to actually do diff. Diff equals this. Now we do if diff smaller than min change and diff or diff larger than max change. Then we say okay, difference smaller, larger, okay. Continue. And here we can do plus plus p1, right? Basically, if we get to here, it's fine. These are exit conditions. The only thing that we need to do is make sure that if we're above that, we need to swap this. And I think this is the correct logic, except we can't do this before this triggers. But if we do this before it triggers, it's just annoying. So what you need to do is like if I yeah, actually we don't need to do this part at all. So if it's larger, then we can swap them over, and else we can do else. So this is the first. We can just do let me see, the thing that I need to do, if it's 1, yeah, we only have to do this if it's not 0. It's funny how I can still trip myself up in the simple things, right? Because the first time these are red, the next time we need to shift them over. The first time we don't need to do this check again. Actually, we do need to make sure that we check these, right? Oh no, the first one determines whether it's an increase or not. So this one will be current smaller than next, like this. Yes, I think that should be fine. So let's change our program to run day 2. Oh, I copied it apparently. Let's go here. I should probably also exit part 1. Okay. Oh, I didn't run the test input, I think. Let's see. Test is true. Piece 20, okay. That's certainly wrong. Let's see. That's funny. Because this one needs to be here, actually. Let me also say that valid is true. Valid is false. If valid, and now we do it like this. Yeah. Because we can probably also break out of it. Just if not valid. We can probably actually just do this inside here as well. Because we don't need to do another check once we found that it's invalid. So every time we go through a set of values, we initialize it to true. If we hit a snag, we return it to false. And then we, if it's valid, we increase it. Let's run this again. Okay, let's see where we end up with. Okay, this is fine. Smaller, larger than allowed. Okay. So let's see if we can, did we set, this was 2. I haven't done these yet. So let's run this with without the test, and I should have probably disabled the output, but it's fine. So we have 314 tests that should be valid. Let's see if that's correct. Woohoo! First gold star in the pocket. Okay. Let's see. Let's also put in the actual values so that our test is satisfied next time. Answer P1 like this, and it's valid. The engineers are surprised by the low number of safe reports until they realize they forgot to tell you about the problem dampener. The problem dampener is a reactor-mounted module that lets the reactor safety systems tolerate a single bad level in what would otherwise be a safe report. It's like the bad level never happened. Now the same rules apply as before, except if removing a single level from an unsafe report would make it safe, the report instead counts it as safe. More of the above example reports are now safe. Okay. That's interesting, because you can't just ignore one error, you need to actually revalidate with one extra step. Let's see, because here if you remove this one it's fine. So that, I think that's a tricky one, because my first instinct was, okay, we'll just track the amount of errors, and if one error is there, ignore it. And then there's the matter of which error, which value you need to remove to test it. So that's interesting. Let me see. Basically, once you determine an issue, there can be two possible places that you try. So okay, let's factor this into a function. Let's do bool is valid, and we do have an IEnumerable int values here. We basically have this logic. I'll just sneak in a list, and in this case, who cares? We can do away with this. Let's do bool is valid, int problem index, like this, right? Return true -1. basically we exit early here. So what we can do here is return false I. Same here. So what we can do now is test this. So let's say bool success int problem index result is valid, the values like this. Well, and we can change this to be if valid result. Let's just copy this here. Result is valid. Success, actually. So now if we run this again, it should still work. Is there an issue now? Boom. So that still works, that's fine. We just took this logic, put it into a function, and returned not only the success state, but also where the issue was. So what we can do now is, for part 2, what we can do is, if result, come on, we don't want those extra braces, but success, we can do P2, we can just implement P2, else, right? Check if we can fix this by removing current or next index. Because the issue always arrives with those two. So removing either one of those two should be the fix. Never something else, right? Let me see. At least that's my... I mean, I can brute force it and just test every permutation, but yeah, that's all right. Let's see. Unsafe regardless, sure. Yeah, so here you would have, you test this is fine, then you go here, it's a decrease. So now you can remove this one or you can remove this one, otherwise it won't solve this issue. Actually, it could be the one before that either, right? Do you actually need to have all permutations? Because in this case, let's say you have this example, but the first one is a 9, right? Then removing this first one would solve it, because the issue would be that it goes up here again, but it needs to go down. So it could be one further back if it's the issue is between index 1 and 2. I wonder if you actually need to test all neighbors, like the 2 that caused the issue plus the one before plus the one after. Would be interesting to see. Because basically, like, the issues are tested one by one. So yeah, I think only if the problem arises at index 1, you also need to check index 0. Otherwise, it doesn't matter because the path is set, I think. So that's an interesting one. I wonder if my assumptions there are correct. So yeah, something tells me that if the issue is here, I need to check 0, 1, 2. If it's here, I just need to check this one and this one. Because these two would also already need to be valid. we'll find out soon enough. I'll just try, get an error, and then add more ranges probably. But my reasoning, somehow I think I can get away with doing less, but I'm not sure. I mean, the simple solution would be to do permutations of everything, but that blows up the search space as well, right? Boom, 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 boom. Yeah, it's interesting. So basically we need to slice up the array. So basically we have values except is that by index? Remove. So we probably need to do dot values and then dot var without current is like this, and I need to spend that's something that I don't like. I wish that this would take over the target type of this if it's possible. Like, why won't it do that? Like, now I need to do list int here, when I think it could infer that from just this being a list int. So if nothing is supplied, why not just assume that you want another list int here? I think that's a reasonable assumption. And then we need to do dot remove, and then we do result dot problem index, and then we do var sub result is valid without current, like this, right? If if sub result success is valid, no success. I named them differently. Okay, I should probably not do that. Let's just do var and make sure that I don't rename the value tuple fields, because that can get very confusing. If this is the case, we do p2, else we do this again, but then differently. So we do without current is this, and then we remove problem index plus 1, but only if the problem index is lower than length minus 1. So we do if result dot problem index is larger than values dot count minus 1. So we need to make sure that we can actually remove the last one to test it, and we should probably do the other thing there as well. So we can do this one as well. So we remove that one, and we do the same here. If it's okay, else. Oops. So basically, I think this isn't enough, but for a test case, this will probably pass. So let me just put it in there. So now the test case for 2 is 4. So let's do test is value 4, test is true. Let's see if this satisfies already. Oh, no. I broke part 2. Cool. So yeah, this is my assumption then that I can test the first, need to test the first one as well if index is 1. If result.problem index equals 1, then we do the same. But we remove 0. Else, oops. Let's see if this one was the correct assumption for here. Nope, still not. Cool. So let's do console.write line. We do string join here. We just write the output here. So string.join, comma. I can just do a space here and do values are not valid. What happened to all the other ones? Okay, there are 6 here. I report 1 not valid. What happened to the other ones? Okay, let me step through to see what's happening here. This is interesting. Okay, so this is the first one. This one is valid, okay. This one is the second range, right? 1, 2. This one is never valid, so that is fine. Right, it says there. Which one is this? 9761. Isn't that gap just too big? Yes. Ah, wait. Okay, I need to have it else. 2, 2, 2. Was a bit too quick there. Okay, so let's run this again. Okay. So we have our answer here. This one is interesting. So why doesn't it like that? This is interesting. This one should be fine. Okay. Okay. Let's step through it. Oh, I'm an idiot. Let's use remove at and not the literal remove. This should fix that. Okay. Now I wonder if I can do away with this one, because I don't think this case hits here, right? See this? Yeah, that doesn't hit. Okay, let me just run the actual input and let's get a false answer, because I think the first one can be an issue. I had the same issue this morning, remove instead of remove at. Yeah, hi Nineberry, nice to see you. So yeah, I'm going to get a wrong submission here, just because I want to make sure, and that I'm curious if my test was correct. See, not the right answer. Okay, that is good. I know it's not good, but yes. So now if I re-enable this case, I could have actually just run the numbers and get a different number without submitting falsely. Not my best move. So we get 346 here. See, and now it's 373. Okay. Without index 1 with index 1. Boom. Let me just put this here, and I'm actually going to, because we need to wait a bit before we can submit again. Just going to do this for fun. I actually don't know how big is the input actually. Probably not big enough to actually worry. But I'm just going to, for fun, do this. For int I is 0, I is smaller, max is value that counts, minus 1. I is smaller than max, I. Let me just turn this into this style comment because I want to comment this whole block now. Just for fun. So now what we can do is basically we do this as I. Break like this. So as soon as something is valid, we're fine. So if I run this now, I wonder if I get a bigger number, which would mean that my other logic was false. Ooh, a smaller number. Wait, what? That can't be true. That is interesting. How can I get a smaller number now? That's really interesting. A block. Yeah, for sure. Let's see. Pool is valid is true. No, false. If valid is true. If not, it's valid. It's valid. I actually want to see which ones it no longer thinks is valid here. This just doesn't make sense to me. Oh. Never mind. That's when you cap it twice, right? We don't care here. Let's see. No, 273, it's the same. Okay, so my instinct was right. I actually just need to check problem index 1 and then it's correct. So it's good to verify. Nineberry says you skipped the last number because of -1 and lot. Yeah, glad I figured it out myself, but also very nice to have you here. So here we did the validation. So yeah, basically what I said before was right. Because the first part is used to set it up, if the setup is wrong for the rest, you need to actually go back and remove the first one if you find out that index 1 is wrong. So in this special case, when the first, the index 1 compared to index 2 triggers the failure, you don't need to check, try to remove either one of those, but also need to remove this first one as an option. So that's a special case. You don't need to test everything, but it's always nice to verify. And because when you do a wrong submission, you have like a minute before you can submit again. So we had some time to test. So yeah, and this was just like something that I could reason about, but I wasn't sure if it was all the things that I needed to reason about. So that's why I wanted to make sure that there isn't another case that I'm missing, because if this number would end up higher, yeah, that would be an issue as well. So now we can just say, okay, our answer should be for this. So if we submit it now, woohoo, second gold star. So yeah, that was nice. It actually made me think. I caught the extra case. I could have just tested it without submitting it first, but yeah, this is fine. So this refactored stuff can go away because we used a function here. So yeah, I'm happy that I caught this before I ran into the issue and was able to reason about it. Did anybody else do it this way, or did you just brute force it and test all of them? Or curious to see what the rest did. Did somebody else run into this issue that you just test the one that has the issue and the next one, but not the first case in this special case? As always, feel free to drop something in the Discord, in the show off your stuff. Let me see, I can probably invite people and copy a link. So if you're not in the Discord yet, you can do this. Nineberry said I just brute forced. It's totally fine, especially for this early on. I think we can take a look at Smabs because he probably committed day 2 already. Let's see, what did he do? Haha, something that's interesting. Is this his own extension or something new? Because I wrote like an as parser a while ago, but I use it to create all sorts of Frankensteins, so that's fine. Let's see. Solution is safe, reports just count is safe. Okay, so this is sure. It passes a logic thing in there. Let me see, has min-max gap. Ah, this is cool. I haven't done this yet. This is like one of those new language features. So if you want to test multiple things, you can do a statement and then is, and then I like this way of writing it. So you can go here and basically you can say diff is smaller than min change and larger than max change. Basically it's or. So you have a more natural language query like this. The only thing is that it's so small. The blue is here and the tint change between the variable, but when it's so small like this, I'm not sure if I like it. In this case, when like the statement is more complex, as in you have multiple things coming together, not having to declare a variable for it and just target it twice, because that's something that you usually that's usually an issue, right? You have maybe a few statements together that produces a value that you want to test against two things. Normally the only way is either to do the build-up of that value twice to test it, or put it in a temporary variable. Having this is something where you can just have something that you can target multiple times in a statement. So yeah, it's nice. Especially like when it's like this, when you already have a variable. Somehow for me it didn't read as nice, so I was like, hey, I really like this, and then when I put it with my single variable and target it this way, I found it less nice. But it's really nice when you have like a compounding, like maybe a try get value, and then you have like a typecast and a when null value, etc. And then you can wrap all of that and then target it multiple times. I really like it for that. Nineberry says it's especially useful in Switch. Yeah, the new Switch. The new language features are nice. They are nice additions, I must say. Let's see, has sign. First, second, pair in sign. Ah, okay. Sure. So this basically what it does, it checks is it positive or negative, and then it compares it to the previous one. Okay. And then you zip it again. I thought about this because this is like we said yesterday. We used it in day 25 to match it against itself. yeah, it's fine. I don't know why my mind never goes to zip, because when I was coding it, I was like, sure, like the for I loop, right? This, and target, current, and next. In my mind, before I wrote this, I was like, I could zip it against itself. And I was like, nah, I don't know why there's something in me that just doesn't go for the new thing right away. Maybe it's just because I don't use it that much, but yeah, because this would basically become so values.zip, values.skip, 1, and then do you get AB here, like this? Oh. Something like that, right? Yeah. Yeah, okay. So you do this, and then you can have the logic inside here. Basically, this would then become cur next. It becomes a bit more messy here with the logic there, but yeah, if you don't need the data, it doesn't matter. It's tolerable by safety. Okay, this also just checks all of them, right? Yeah. Sure. Yeah, I was happy that I found a way to... there's 9 berries. I was happy that I saw a way to optimize it and make sure that I could test just for this extra case. So if like the range of values would be like 5,000 in a row, this would save a lot of time. Let's see. Reports. I don't do this. I saw Smap do this as well a lot. Like to write a Boolean function and then pass that into a link function. I'm always tempted to either just write it inline there or yeah, this is neat. Let me see. Is safe with dampener. Check apps. Okay, let me see what this does. Okay, this is the actual set of offset values that it allows. So you just check it twice. Let me see if I understand. Was this because you assumed something like this would change in the second one, where you could have like only powers of 2 are allowed or something like that? Let's see, is safe with them, not to improve performance by being smarter, and is safe and not actually trying out all the bit. Yeah, okay. Well, I got a suggestion for you here. Yeah, I speculated part 2 would be something like 1, 3, 5. Yeah. So yeah, basically, if the index that fails is 1, make sure to also check 0. Or you can blindly just always check 0. That would also work. But the fastest would be only if like the index 1 to 2, if that one fails, to also try removing the entry 0. Okay, cool. It's fun that there's even something to talk about with like day 1 and day 2 challenges. Maybe it's just me that I need to learn more, but in my mind it was always, hey Nineberry, welcome to the Discord club. In my mind, and maybe my mind isn't that great again, but like in the past, Advent of Code day 1 and 2 was like, okay, zip, done. And now I actually have to think already on day 2 and learn something again for day 1. So yeah, I'm just happy that Advent of Code is here again. I'll probably curse it in a few days when the difficulty jumps up and you have something impossible, like the Chinese remainder theorem thing from a while ago. I really liked one where you had to like subdivide in 3D space. That was really fun, but it took me so much time. And like when you had the Loch Ness monster that you had to map out, etc., with all those tiles. Those were really fun, and I built like tools, etc. Like the tough ones where you come out ahead at the end, those are really fun. But yeah, I think that concludes today's stream. I want to thank everybody for keeping me company again and sharing your code, and yeah, it's been nice to do Advent of Code again and have some people here. So thank you, and hopefully see you again tomorrow. Bye bye.